Hello, today we're doing lesson 6.2 and I broke this section up into 3 different sets of notes. So today we're going to apply properties of rational exponents. Now, properties of rational exponents are the same properties as regular exponents. It's just that we're going to be dealing with fractions. So we're going to be adding, subtracting, and multiplying fractions. So don't freak out. And if you want to use your calculator, make sure when you put a fraction in, you're using the division sign and you put parentheses around the fraction. But we'll talk about it. These are the pretty simple fractions. You should be able to add, subtract, and multiply them without using your calculator. Okay, number 1. So look at this problem. I have like bases. I have 7 and 7. When I have like bases, I know that I'm going to add the exponents. So you're adding 1/4 plus 1/2. Remember, when you add fractions, you need to get a common denominator. So I get 1/4 plus 2/4 equals 3/4. So you write your answer as 7 to the 3/4 power. Now, if you can simplify it, I would like you to simplify it. But remember, the bottom number is what root we're taking. We can't take the 4th root of 7, so we leave our answer as that. Okay, this one, I'm raising a power to a power, so I'm going to multiply fractions. Remember, when you multiply fractions, you multiply the numerators, so you get 2 times 1, and then you multiply the denominators, so you get 3 times 2, which is 6. I would like you to reduce the fraction because you can, so you get 8 to the 1/3. Now this problem, I can take the cubed root of 8. I know that the cubed root of 8 is 2. So I actually want to see your answer as 2. If you left it as 8 to the 1/3, I probably would take off a point because it isn't reduced. Okay, now this one. Number 3, we're dividing. Remember, when we divide like bases, we subtract exponents. This top 5 has an exponent of 1. So you're doing 1 minus 1/3. I can change this 1 into 3/3. So when I subtract those fractions, I get 2/3. Where do you put 2/3? Where's the bigger exponent on top? 1 is bigger than 1/3. So my answer is 5 to the 2/3. I know I cannot take the cubed root of 5, so I stop. Okay, now this problem, if you take a look, because these two exponents are equal, you can kind of separate it out. Okay, I can look at it as 21 over 7 all to the 1/2 power. We'll bring that 3 in a second. Because they're the same exponent, I can actually divide. I get 3 to the 1/2. Now you're not done. We still have to raise that to the 3rd power. So when I do that, you multiply, so you get 3 to the 3/2. I cannot take the square root of 3, so I leave this as my answer. Remember, you're always looking at that bottom number. That's your root. Can I take the square root? In this problem, was it, can I take the 4th root? In this problem, can I take the cubed root? Okay, let's just go ahead and continue practicing. Okay, now, look over at this problem. This is about as tricky as it gets. Right now, I don't have like bases. You cannot subtract exponent. Now, can you make like bases? You can, because 49 is the same as 7 squared. 343 is the same as 7 cubed. Okay, I want you to do that first. Now, these exponents are still there. So what you end up doing is multiplying. So 2 times 5, 6. You're only multiplying the top, the 2 and the 5. So you get 7 to the 10/6. Bottom, we're going to multiply by, 2/3. So I get 7 squared. Now, you can look at this a little simpler. I like to look at it, I can take a 2 out of both of these. So I get 7 to the 5/3 over 7 squared. And then you're subtracting you're dividing like bases, so you're going to subtract the exponents. 2 is actually bigger than 5/3, so 2 minus 5/3. If you want, try putting it in your calculator. Otherwise, we can make them have a common denominator by multiplying this fraction by 3/3. So you get 6/3 minus 5/3 is 1/3. Now the bigger exponent is on the bottom, so that's where we want to keep it. 1 over 7 to the 1/3. And like I said, that's about as tricky as it gets. You have to change the bases. Okay, now this one, be careful here because these are not like bases. I cannot combine those. So what I'm going to do is I'm going to go ahead and raise both of those to the -1/5 power. So when I do that, I get 4 to the -1st times 3 to the -1st. I do not want you to leave your answer with a negative exponent, so we're going to move both of them down. 4 to the 1st and 3 to the first. And you can go ahead and multiply those because they're both to the first power, so 1 over 12. That's it. So I think what students find challenging about this section is that each problem is a little bit different. I want you to try the 2 U tries. Do not leave it blank. I want you to look back at an example that I have similar, okay? Now, we didn't do an example like this, okay, but we did the division one, like number 2. So I'll give you a hint on number 1. Change them so they're like bases. So 16 is 4 squared, then multiply by the exponent that's there. 64 is 4 cubed, so multiply by the exponent that is there. And then you might be able to reduce it because we can also have them have like bases of 2. We'll talk about that in class. Go ahead and get started with that one. Okay, any questions, comments, or concerns? I'll write at the bottom of the paper, and I'll see you tomorrow in class.